Have you ever wondered why, even with supercomputers crunching numbers, some problems remain unsolvable? Why can't our powerful machines predict earthquakes accurately, or design life-saving drugs with ease? The answer lies in the fascinating world of quantum mechanics, where the rules of classical physics cease to apply. Our current computers, based on bits, have limitations. They struggle with the complexity of the quantum realm. But what if we could harness the power of quantum mechanics to build a new kind of computer? This is where the incredible potential of quantum bits, or qubits, comes into play. Get ready to dive into the mind-blowing world of quantum computing. Imagine a coin. You flip it, and it lands on either heads or tails, right? This is how classical bits work. They are either a 0 or a 1, representing information in a binary way. Now imagine a special coin that can be both heads and tails at the same time. Mind-boggling, isn't it? This is the basic idea behind a qubit. A qubit utilizes the principles of quantum mechanics to exist in a state called superposition. It's not simply a 0 or a 1, but a combination of both possibilities simultaneously. Think of it like a spinning coin that hasn't settled yet. It's in both states until we measure it. Let's dive a bit deeper into the world of qubits. They're not physical coins, of course. In reality, qubits can be created using various quantum systems like trapped ions, photons, or superconducting circuits. These systems have a unique ability to exist in multiple states at once, thanks to superposition. It's like a light switch that can be both on and off simultaneously, allowing for a much richer representation of information. This mind-bending property of qubits is what sets them apart from classical bits and unlocks the potential of quantum computing. Superposition is just the tip of the iceberg when it comes to the wonders of quantum mechanics. Another bizarre phenomenon is entanglement. Imagine two of our special coins, linked in a way that even if you flip and separate them by miles, knowing the state of one instantly reveals the state of the other. This is entanglement, a spooky connection between qubits that allows them to influence each other instantaneously, regardless of distance. By harnessing superposition and entanglement, quantum computers can perform calculations in parallel, exploring multiple possibilities simultaneously. This parallel processing power is what makes them exponentially faster than classical computers for certain tasks. Alright, let's compare qubits and classical bits head-to-head. So, when it comes to state, a classical bit can be either 0 or 1, but a qubit can actually be 0, 1, or both at the same time. For an analogy, think of a classical bit like a light switch. It's either on or off. But a qubit is more like a spinning coin, kinda in between heads and tails until you look at it. In terms of processing, classical bits work sequentially, doing one thing after another, while qubits can process information in parallel, handling multiple things at once. And finally, when we talk about power, classical bits are well limited, but qubits have exponential potential. So as you can see, while a classical bit is limited to a single value, a qubit can explore multiple possibilities at once. This fundamental difference is what gives quantum computers their incredible potential. The unique capabilities of qubits have the potential to, totally revolutionize various fields. For instance, in medicine, quantum computers could accelerate drug discovery by simulating molecular interactions with unprecedented accuracy. This could lead to the development of new treatments for diseases like cancer and Alzheimer's. In the world of cryptography, qubits can be used to create virtually unbreakable encryption methods, ensuring secure communication and data protection in a world that's honestly more reliant on digital information than ever before. When it comes to material science, by simulating the behavior of materials at the atomic level, quantum computers could pave the way for the discovery of new materials with enhanced properties, and that could seriously revolutionize industries from electronics to energy. And in climate science, quantum simulations could help us understand and predict complex climate patterns more accurately, leading to more effective strategies for mitigating climate change. These are just a few examples of how qubits are, seriously poised to change the world as we know it. So, hit that like button if you're excited about the possibilities. We are still in the early stages of quantum computing, and there are, honestly, some pretty exciting challenges ahead. First up, building stable qubits. They're extremely fragile and susceptible to environmental noise. Researchers are working hard on developing more stable qubits that can maintain their quantum states for longer durations. Then, there's the challenge of scaling up quantum computers. Building large-scale quantum computers with millions or even billions of qubits is a monumental task that requires overcoming some significant engineering hurdles. And let's not forget about developing quantum algorithms. To fully harness the power of quantum computers, we need to come up with new algorithms that are specifically designed to leverage their unique capabilities. Despite all these challenges, the future of quantum computing is, honestly, looking pretty bright. With continued research and development, we can unlock the true potential of qubits and usher in a whole new era of technological advancement. From revolutionizing medicine to cracking the code of complex scientific problems, qubits are, totally poised to transform our world in ways we can only begin to imagine. While the journey of quantum computing is still unfolding, one thing is for sure: the future is quantum, and it's just brimming with possibilities. So, what excites you most about the potential of qubits in quantum computing? Share your thoughts in the comments below. Did you enjoy this journey into the world of qubits? Don't forget to subscribe for more mind-blowing content exploring the frontiers of science and technology. Let's keep the conversation going. Hit that like button, share this video with your friends, and join the quantum revolution.